Hello, this is Mr. Jones, and I'm going to talk to you today about similar figures and scale drawings. Here I have two trapezoids, trapezoid ABCD and trapezoid EFGH, and they are similar. And the reason I know this is because of this symbol right there. That symbol right there tells me that these two figures are similar. So anytime you see the little squiggly line like that, it means similar. Right? It's telling me that these two figures are similar. And similar figures have the same shape, but not necessarily the same size. Similar figures have corresponding angles and corresponding sides. So here, angle D corresponds to angle H, and side DC corresponds to side HG. And I can look at the initial problem, and it tells me that point A corresponds to E, point B corresponds to point F, and so on. So it's easy to see what sides correspond with each other. Similar figures have two properties. The corresponding angles are equal, and the lengths of corresponding sides are in proportion. So corresponding angles, so angle D corresponds with angle H, so those two angles would be equal to each other. And corresponding sides, DC corresponds to HG, and they would be in proportion. So if I'm looking for the measure of K, I can set up a proportion as long as I know enough information from the other sides to set up a proportion. So I'm going to set up a proportion to solve for K. And I usually like to set up my ratio as small to large. So I'm going to say 2 is to 3, okay? 2 is to 3 as K is to 6. So notice how I set up the corresponding sides. And I'm, again, going small to large with my ratios. So then I can use this and solve the proportion for K. So 3 times K is 3K, and that would be 2 times 6. So my cross products are there, and then I'm going to solve. So 3K is equal to 12. Divide both sides by 3, and I get K is equal to 4. So K is equal to 4. You can use similar figures to compute distances that are difficult to measure directly. Such a process is called indirect measurement. Here I have a tree and a small boy, and I want to find out how tall the tree is. Now, they're standing out at the same time, and they each cast a shadow. And for the tree, the shadow is about 10 feet long. Right? And again, I'm looking for how tall is the tree. And so I can draw a shape that looks a lot like a triangle. And I could do the same thing with the small boy. Right? Draw his height. And I know his height is 5 feet. Right? And he cast a shadow that is 4 feet. And again, I draw a similar triangle. So I have two triangles here that are similar, and I can use the corresponding sides because they are in proportion to find out how tall the tree is. So I'm going to set up my proportion. Again, I like to go small to large. So I'm going to use 4 is to 10 as 5 is to x. Now that I have my proportion set up, I can solve for the height of the tree simply by using the cross products. So 4 times x is 4x is equal to 10 times 5. So 4x is equal to 50. Divide both sides by 4, and I get x is equal to 12.5. So the tree is 12 and a half feet tall. Next, I'd like to talk to you about scale drawings. A scale drawing is an enlarged or reduced drawing that is similar to an actual object or place. The ratio of a distance in the drawing to the corresponding actual distance is the scale of the drawing. You see scales used in architectural drawings or in maps. You would even see them in models if you've ever built a model airplane or something. So I can use this scale to solve for the actual distance or actual measurement. Let's take this example here. The scale of the map is 1 inch is to 40 miles. About how far from Atlanta is Athens? In map distance, it measures 1.5 inches. The nice thing about scale is that it always gives you one of the ratios for the proportion. So I have 1 inch. 1 inch is to 40 miles. So I want to set up the next ratio for my proportion, which would be equal, and I know it's going to be inch to miles. And since I already know that it's 1.5 inches, and I'm looking for how far is that in actual distance. So now I have my proportion set up, and I can solve from that. So I have 1 inch times x. So 1 times x, I'm just doing the cross products here, and then 40 times 1.5. And this should help solve for what x is. So 1 times x is just x, and 40 times 1.5 is 60. So the distance between Atlanta and Athens is about 60 miles. I hope this helps.